The Andromeda mystery, an unexpected cosmic puzzle. Our galactic neighbor, the Andromeda Galaxy, also known as M31, is currently presenting astronomers with a baffling enigma. Much like our own Milky Way, Andromeda is orbited by a collection of smaller dwarf galaxies. However, recent observations have revealed something that defies our current understanding of galaxy formation, a strikingly one-sided arrangement of these satellite galaxies. Under the standard cosmological model, these dwarf companions should be scattered randomly around their host galaxy. But Andromeda's satellites are anything but randomly placed. A team led by Osuki Jamie Kanehisa from the Leibniz Institute for Astrophysics in Potsdam took a closer look. Using updated data on 37 satellite galaxies, they found that, with only one exception, all of these companions lie within a cone-shaped region covering just 107 degrees, pointing roughly toward the Milky Way. This means nearly all of Andromeda's dwarfs are grouped on just one side, covering only 64% of its orbital space. Even more curious, about half of these satellites are aligned along a single orbital plane, much like the planets in our solar system orbiting the Sun. This dual anomaly, a skewed distribution and a flat orbital alignment, is extremely rare and difficult to reproduce in simulations based on current models. To investigate further, the research team analyzed over 300 simulated galaxies, looking for similar asymmetries. The result? Only one system displayed a distribution as lopsided as Andromeda's. Statistically, this makes Andromeda an extreme outlier, raising serious questions about our understanding of galactic formation and behavior. What could be behind this strange formation? One theory suggests that Andromeda may have absorbed a group of dwarf galaxies in a single, recent event. Another possibility involves the gravitational pull of our own Milky Way influencing Andromeda's satellites more than expected. But so far, none of these explanations fully account for what we're seeing. As the researchers note, at present, no known mechanism can explain the asymmetric arrangement of Andromeda's companions. But Andromeda isn't done surprising us. A newly discovered satellite galaxy, named Andromeda 35, adds another twist. Found during the Pan-Andromeda Archaeological Survey and later confirmed by the Hubble Space Telescope, this dwarf galaxy is exceptionally small and faint, so dim, in fact, that it resembles the tiniest known satellites of the Milky Way. But there's a key difference. While most of the Milky Way's dwarf galaxies stopped forming stars around 10 billion years ago, Andromeda 35 continued birthing stars until just 6 billion years ago. This contradicts previous theories suggesting that galaxies of this size, especially in the early, high-radiation universe, should have lost their gas and ceased star formation. This unexpected discovery could reshape our understanding of galaxy formation. The newly observed behavior of Andromeda's dwarf galaxies, particularly their skewed distribution and unexpectedly prolonged star formation activity, suggests that the early universe may have been far more dynamic and complex than previously imagined. Contrary to long-standing theories, it now appears that some small galaxies might have managed to retain their star-forming gas much longer than expected, challenging our assumptions about cosmic heating and gas loss caused by early energetic phenomena like supernovae and black holes. Advanced observatories like the James Webb Space Telescope, JWST, and the upcoming Nancy Grace Roman Space Telescope may soon provide critical data to help resolve this enigma. By peering deeper into the cosmos and further back in time, these instruments could reveal whether Andromeda's satellite behavior is an isolated case or part of a broader, unexplored galactic pattern. Will the Milky Way and Andromeda actually collide? For decades, it was considered an inevitable fate. In about 4 billion years, the Milky Way and Andromeda galaxies would crash into each other, spiraling together into a single, massive elliptical galaxy that astronomers whimsically dubbed Milkromeda. This cosmic ballet was seen as a certainty, backed by detailed simulations and gravitational calculations. But now, even this prediction is being questioned. Recent simulations, spearheaded by Dr. Till Soala and his team at the University of Helsinki, have added new variables into the mix, specifically, the Large Magellanic Cloud, LMC, and the Triangulum Galaxy, M33, two significant members of our local galactic group. Updated mass measurements and revised trajectories for all four galaxies have introduced surprising shifts in predicted outcomes. The Large Magellanic Cloud, in particular, plays an unexpected role. It's moving almost perpendicularly to the orbital path of the Milky Way and Andromeda. When this fast-moving dwarf galaxy passes close to our own, it could exert enough gravitational force to alter the Milky Way's trajectory, effectively preventing a direct collision with Andromeda. As a result, the once assumed certainty of a galactic merger is now a cosmic coin toss, with just over a 50% probability. The future formation of Milkdromeda is no longer inevitable, it's merely possible. A universe full of surprises. What does this all mean? It means that the universe, even at scales of millions of light-years, remains unpredictable. It reminds us that our models, though powerful, are still limited, and the cosmos constantly challenges us to refine them. From the peculiar plane of Andromeda's dwarf satellites to the uncertain fate of our galactic future, each new discovery reshapes the story of the universe. Astronomers will continue to explore these mysteries with ever more sensitive instruments, running larger simulations, collecting deeper images, and developing sharper theories. And with every answer comes a new question. So as we gaze toward our closest galactic neighbor, let us remember, Andromeda is not just a beautiful smudge in our night sky, it's a living puzzle box filled with clues about the very nature of existence. Stay curious. The universe is still writing its story.